Assalamualaikum warahmatullahi wabarakatuh. Perkenalkan, nama saya M. Arif Rahman dari kelas TI23E dengan NIM 23416226201111. Saya akan menjelaskan proses pembuatan piringan rem atau disc brake melalui proses machining. Yang pertama, apa itu disc brake? Piringan rem atau disc brake adalah komponen penting dalam sistem pengereman kendaraan yang berfungsi untuk memperlambat atau menghentikan laju kendaraan melalui gesekan dengan kampas rem. Kualitas dan presisi piringan rem sangat memengaruhi kinerja pengereman dan keselamatan berkendara. Yang selanjutnya ada material. Yang pertama ada bahan umum, yaitu besi cor kelabu atau gray cast iron karena memiliki konduktivitas termal yang baik dan tahan aus. Yang kedua ada bahan alternatif, yaitu baja karbon rendah seperti S45C atau komposit karbon keramik untuk aplikasi performa tinggi. Selanjutnya ada proses pembuatan. Yang pertama, pembuatan pola, yaitu membuat pola piringan rem yang akan digunakan untuk cetakan. Yang kedua, pengecoran atau casting, melelehkan logam dan menuangkan ke dalam cetakan untuk membentuk piringan kasar. Yang ketiga, perlakuan panas atau heat treatment, yaitu meningkatkan kekerasan dan ketahanan material melalui proses pemanasan dan pendinginan terkendali. Yang selanjutnya ada permesinan kasar, yaitu menghilangkan kelebihan material dan membentuk dimensi awal. Yang kelima, ada pemesinan presisi, yaitu mencapai dimensi akhir dan toleransi yang diinginkan. Selanjutnya, ada finishing, yaitu menghaluskan permukaan dan memastikan keseimbangan piringan. Dan yang terakhir, ada kontrol kualitas atau quality control, yaitu memeriksa dimensi kekerasan dan keseimbangan untuk memastikan kualitas produk. Selanjutnya ada proses machining detail. Yang pertama ada turning, yaitu membentuk diameter luar dan dalam piringan. Yang kedua ada drilling, yaitu untuk membuat lubang pemasangan. Yang ketiga ada drilling, yaitu untuk menghaluskan permukaan kerja dan memastikan kontak yang baik dengan kampas rem. Selanjutnya ada finishing dan inspeksi. Yang pertama ada balancing, yaitu untuk menyeimbangkan piringan dan menghindari getaran saat digunakan. Yang kedua, surface treatment, yaitu mengaplikasikan lapisan pelindung untuk mencegah korosi. Dan yang terakhir ada inspection, menggunakan alat ukur presisi untuk memastikan dimensi sesuai dengan spesifikasinya. Berikut adalah contoh video proses pembuatan disc brake.
Brake discs. They're not the flashiest part of a car, and they definitely don't get the same love as a sleek body or a roaring engine. But make no mistake, your vehicle owes a huge part of its stopping power to these heavy-duty, often overlooked pieces of metal. They sit there quietly behind the wheels, enduring intense heat, friction, and pressure every time you tap that brake pedal. But how exactly are these discs made? How do they go from raw, unassuming metal to those perfectly round-grooved and reliable components of your car's braking system? Today, we're pulling back the curtain on the surprisingly complex process of how brake discs are manufactured. From molten metal to high-performance machinery, right here on History of Simple Things. It all begins with iron. Not just any iron, though. We're talking about cast iron. Specifically gray cast iron. It's the go-to material for most brake discs because it's strong, heat-resistant, and cost-effective. Some high-performance or specialty discs might use carbon composites or ceramic materials, but for the majority of everyday vehicles, cast iron is the MVP. Manufacturers usually get this iron in scrap form, old car parts, leftover machining bits, and other recycled metal pieces. These scraps are collected, sorted, and then melted down in massive furnaces that can reach temperatures of over 1,500 degrees Celsius. That's hot enough to turn solid metal into a bubbling, molten soup of iron. Once the scrap iron is fully melted, it's time for casting. But before we get into that, let's talk about molds. Brake discs aren't just poured into any old container. They're formed using specialized sand molds made with extreme precision. These molds are created by compacting a mixture of fine sand and binding agents into a cavity shaped exactly like the final brake disc. Sand might seem like an odd choice, but it can handle the intense heat of molten metal without breaking down, and it captures fine details exceptionally well. Now, with the mold ready and the iron hot, the molten metal is carefully poured into the cavity. It's a tense moment. One wrong move, and you've got a ruined mold or a dangerously flawed disc. But if everything goes according to plan, the liquid iron fills every corner of the mold, then slowly begins to cool and solidify. This part of the process is critical. If the metal cools too quickly, it might develop internal stresses or cracks. Too slow, and you risk structural inconsistencies. Once cooled, the sand mold is broken open and the newly cast brake disc is freed, still rough around the edges, but finally taking shape. At this stage, the disc is what's called a casting blank. It looks like a brake disc, sure, but it's not ready to hit the road just yet. Cast iron, as strong as it is, needs a little help to ensure it'll perform well under the extreme conditions of real-world braking. So, the disc undergoes heat treatment, a process that relieves internal stresses caused by the casting and cooling process. Think of it like a stress-relieving spa day for metal. The disc is placed in a furnace again, but this time, it's not to melt, it's to bake. It stays at a controlled high temperature, then cools slowly in a carefully regulated environment. This process, known as normalizing, helps the metal settle into a stable structure, making it less brittle and more durable over time. Now comes the transformation from a rough, raw casting to a precise, road-ready component. This is where the machines take over, and it's no small job. Specialized CNC, computer numerical control machines, grind, cut, and shave the disc down to exact measurements. Remember, brake discs have to be perfectly balanced and uniformly shaped. Even a slight wobble could lead to poor braking performance, vibrations, or even dangerous failures. Machining includes smoothing out the surface where the brake pads will press, drilling holes if it's a ventilated or slotted disc, and finishing off the central hub that connects to the wheel. The tolerances here are tight, often within fractions of a millimeter. The surface is also finished with specific patterns, like grooves or cross-drilled holes, depending on the disc's design. These aren't just for show. They help dissipate heat, reduce brake fade, and improve water dispersion in wet conditions. Once machining is done, it's time for balancing. Think of a brake disc like a spinning top. It has to rotate smoothly, or else the car will shake every time you hit the brakes. To balance the disc, manufacturers use high-speed rotation tests to detect any imbalance. If a heavy spot is found, tiny bits of material are shaved off, or small corrective weights are added. This balancing act ensures that once the disc is installed, it will spin smoothly and evenly at any speed. After balancing, the discs go through rigorous quality control checks. This includes visual inspections, dimensional measurements, and in some cases, X-ray analysis or ultrasonic testing to check for internal defects. Some discs are even tested on dynamometers, massive testing rigs that simulate real-world driving conditions, to see how they handle temperature, stress, and wear. Only after passing all of these tests is the brake disc ready to be boxed, labeled, and shipped out to either the automaker or the aftermarket parts distributor. Some brake discs receive a little extra treatment before heading out the door. Depending on their intended use, manufacturers might apply anti-corrosion coatings or paint the hub area to prevent rust. Others, especially in the performance market, are treated with high-tech coatings like zinc or carbon to improve heat resistance and durability. There are even carbon ceramic brake discs used in supercars and racing vehicles, which go through a completely different and far more complex process involving carbon fiber and silicon carbide. But for the average car, the good old cast iron disc, with maybe a protective coat of anti-rust paint, is more than enough to do the job reliably and safely. So the next time you slam on your brakes and feel your car come to a smooth, steady stop, remember, there's a lot more going on behind those wheels than you might think. That disc isn't just a hunk of metal, it's the result of fire, engineering, precision machining, and rigorous quality control. It's designed to be abused, heated, and pushed to the limit, again and again without failing. That's a pretty impressive resume for a part that most people never even see. And now you know, brake discs don't just appear on cars, they're forged, formed, and finessed into the unsung heroes of road safety. Thank you for watching. If you have suggestions for our next video, feel free to share them in the comments below. We'll be sure to give you an acknowledgement for your contribution. Thank you for joining us on this journey through the history of simple things. Don't forget to like, subscribe, and stay tuned for more stories woven through the smallest details.
Yang terakhir ada kesimpulan. Yang pertama, pembuatan piringan rem melibatkan serangkaian proses mulai dari pengecoran hingga finishing. Yang kedua, presisi dan kontrol kualitas yang ketat diperlukan untuk memastikan kinerja dan keselamatan piringan rem. Dan yang terakhir, inovasi dalam material dan proses manufaktur terus dikembangkan untuk meningkatkan performa dan efisiensi pada produksi. Cukup sekian penjelasan dari saya. Kurang lebihnya mohon maaf. Wassalamualaikum warahmatullahi wabarakatuh.